Alright guys, we're back. We gotta finish up these exponent laws. The two we're going to talk about today, kind of the opposite way of thinking when we dealt with product of powers and powers of powers. If you thought about it, you know, products and quotients, multiplying like bases and dividing like bases, multiplying and dividing themselves are opposites. So I'm pretty sure you can guess what the rule is going to be, since when we multiplied like bases, we added exponents. So I'm pretty sure you guys probably already understand what we do when we divide like bases. I'm going to show you two different ways. I'm going to show you why the rule works, and then I'm going to show you the rule. When I first teach this, I don't like the quotient rule because of the fact that some students don't have great integer skills, number sense. And you'll see what I'm talking about in some of these examples. But let's go through these real quick and let's get this done. Also, remember, this only works with like bases. If you don't have like bases, you can't do anything with them. So when you're going through these problems, guys, make sure you're paying attention to which bases are the same. Okay? Alright, first one. We have 4 to the 5th over 4 cubed. Now again, I'm not going to do 4 times 4 times 4 times 4 times 4. I'm not going to do 4 times 4 times 4. Okay? I will expand it to show you what really happens. But I don't actually care what the answer is when you multiply all these out. Now, if you guys remember anything about division, the basic concept of division, we know that when we're dividing, they kind of cancel each other out. And canceling is a bad term to use here, because when you divide something by itself, it doesn't really cancel out. It divides into 1. We know 6 divided by 6 is 1. We know 1,024 divided by 1,024 is 1. We know x divided by x is 1. We know smiley face divided by smiley face is 1. Okay? Anything divided by itself is always 1. So that's the concept we're going to use for this problem. 4 divided by 4 is 1. 4 divided by 4 is 1. 4 divided by 4 is 1. So that's just 1 times 1 times 1. 1 times 1 times 1 is just 1. Times 4 is 4 squared. Which is 16, but I don't really care about that. So you guys see what happens. Yes, the bases kind of cancel each other out, but again, they call this the ugly one, because it's just a weird way of writing 1. Anything divided by itself is 1. Now also pay attention. I have 2 4s in the numerator. When we get into negative exponents, the position of the base is going to be extremely important. So as I go through this, I'm going to be saying the position and where and what variable they have. So I'm going to say 4 squared in the numerator. I have 2 factors of 4 in the denominator. So again, make sure you guys pay attention to that. As you can see, you probably know what the rule is already. If I somehow got 4 squared, and if you understand that dividing is the inverse of multiplication, you probably already understand that the quotient rule is just you subtract your exponents. That's why I don't like the quotient rule, because subtraction, especially when you start throwing in negative integers, guys, it's going to be incredibly error prone. You're going to be able to make mistakes left and right. And you may subtract incorrectly because, let's be honest, the number sense in the 8th grade or even the 7th grade, it's not the strongest. Even I make mistakes sometimes when I'm subtracting negative numbers. So that's why I do this whole, how many variables do I have left where? Okay? Second example, 6m squared n to the 4th over 4m to the 5th n cubed. Now, I'm going to expand it once again. You guys do not have to keep expanding it if you want to. You can if you want to, but you don't have to. So I'm going to expand it. 6 times m times n times n times n times n times n over 4 times m times m times m times m times m times n times n. So if I expand this out, oh, I forgot an n. There it is. If I expand this out, this is what I have. Now, watch closely as I do this so you can understand my thought process. I have 2 m's in my numerator. I have 5 m's in my denominator. Clearly, I have more m's in my denominator than my numerator. That means at the end of this problem, I'm going to have m's left over in my denominator because that's where the majority of them are. If I start making them 1's, I can get rid of 2 of them. That means I have 1, 2, 3 left down here. I do not bring these up. I do not at all. I keep them there. If I do the ends, they're kind of misaligned, so I'm just going to scratch them out. I have 4 up top and 3 in the bottom, so 1 goes away with 1, 1 goes away with 1, and 1 goes away with 1. That means I have 1 left in my numerator. So I really have n, m, 1, 2, 3, nm cubed. Boom! Now you're probably wondering, Mr. Z, what happens with the numbers? Do I subtract these two? God, no, guys. Just like when you do the power of the product rule, product of the power rule, or product of powers, you actually multiply the bases together. In this case, since it's the quotient of powers, you divide them. 6 divided by 4 doesn't go in evenly, but you can reduce these. 2 goes into both 6 and 4. That leaves 3 over 2. 3n over 2m cubed. Now, some of you are probably thinking, Mr. Z, I subtracted these, and I got 3 halves, m to the negative 3, and n. Because when you do subtract 2 minus 5, you get negative 3. This is also correct. That's also true. Both of these are actually synonymous. They're equivalent. They're the same thing. And you're going to see why down the page. But for now, guys, I really don't want you using the quotient rule. I'd rather you think about it and say, all right, I have 2 up top, I have 5 on the bottom. That means I'm going to have 3 left over in the bottom, in my denominator. Start thinking about it that way. The quotient rule, I'm not its biggest fan. And you're going to see why we can't have negatives anyways. So if you actually end up with a negative, you're going to make more work upon yourself in the end. So please try to do it this way. I'm not saying expand it. I'm just saying think about it in your head. Write the answer down. Last one, 6n to the 7th over 3n to the 8th. Now, all cubed. So you're probably thinking, all right, I have a quotient of a power, and I also have a power of a power. Which do I do first? Here's the thing. It doesn't matter mathematically. You can do either one first. It will not make your answer different. Just like how when you solve equations, you can do different steps at different times. You'll still end up in the same answer. In this case, guys, a word of advice. If I were to distribute this 3 to every single exponent, yes, every single one, to the 6 cubed, it'd be n to the 7th cubed, it'd be 3 cubed, it'd be n to the 8th cubed. Again, everything inside the parentheses, you're going to start getting very large numbers. My advice to you is reduce it down a little bit and then cube everything. So for example, if I'm looking at this, I know 6 divided by 3, that's just 2. I have 7 n's in my numerator. I have 8 n's in my denominator. So if I think about it, all 7 of these will go away. 7 of these will go away. How many do I have left over? I have 1. Now, if I bring this 3 in, it's going to be 2 cubed over n cubed, and we know 2 cubed is just 8. So my answer is 8 over n cubed. Again, guys, notice how I went about that. I didn't expand it out this time because that would have taken some time, and I'm running out of space. But I thought to myself, all right, 7 factors of n up top, 8 factors of n in the denominator. So once I start canceling them out like I did over here and over here, once I start dividing the n's out, 7 n's will divide out with 7 n's. I'm going to have 1 n left over in my denominator. So I keep it in my denominator. I don't switch it. I just keep it there. Cube everything. 8 over n cubed. You would get the same answer if you were to cube everything first, but again, you'd have some crazy high numbers. 6 cubed is I don't care, and 3 cubed easier, that's 27. But again, you see the picture. Make yourself a little bit easier time when solving these. Reduce quotient rule first, and then the power rule after. You can kind of go by that rule the entire time, but you do as you will. I'm not going to tell you which direction to go. It's your choice. So at this time, guys, you can hit the pause button real quick. Try these next 3 problems on your own. Try to see what happens. Follow my examples. If you don't feel like trying them on your own, shame on you. Do it anyways. Once you're done with all 3, resume back to where we are, and then we can go ahead and solve these 3 problems. So, hit the pause button. I'm going to start working on these. First one, n to the 3/4 over n to the 1/4. That's gross. But, again, if I use my quotient rule, I know I'm just subtracting. Mr. Z, you told us not to use a quotient rule. Yeah, but what does 3/4 of a factor of n really mean? What does 1/4 of a factor of n really mean? In this case, guys, use the quotient rule and make your life a little easier. So it's going to be 9 to the 3/4 minus 1/4, which is actually 3/4 minus 1/4, which is 9 to the 2/4, which is 9 to the 1/2. Now, this is going to mean something. This is actually 3. Sorry, you couldn't see when I was working on it. This is actually 3. I'm not going to tell you why yet. So just remember, this is the answer. But next week, we're going to understand why this turns into 3. But for now, guys, just understand it as 9 to the 1/2. Maybe, if you think about it, you can figure out what the 1/2 really implies. What do you do with it? No, you don't divide 9 by 1/2. That's not what the factor means. That's not what the exponent means. But, yeah, it's 9 to the 1/2. Next, 3 squared m to the 5th t to the 6th over 3 to the 5th m to the 7th t to the negative 5th. So, in this case, I'm going to start working with my quotient rule. I know I have 2 factors of 3 in the numerator. I have 5 factors of 3 in my denominator. If I take away 2 of these factors here and here, I have 3 factors left down here. So again, 3 factors in my denominator. I have 5 factors of m up top. I have 7 factors of m on the bottom. So, if all 5 go away, I have 2 left over down here. Again, 5 go away here, 5 go away here. I have m squared left over. Finally, Mr. Z, I don't understand what t to the 5th really, negative 5th really means. How many factors is that? Trust me, guys, you'll learn in the bottom part very shortly what it is. But when you get a negative exponent right now, we're going to use the quotient rule, which implies we subtract our exponents. 6 minus negative 5. Notice how I subtract a negative. That really just means 6 plus 5. And that really gives me t to the 11th. Mr. Z, why is it in the denominator? I mean, why is it in the numerator? Why is it not in the denominator? What's going on? What's happening? Why is this Guys, whenever you use a rule, whenever you use the quotient rule, whatever answer you get has to be in the numerator. It has to be. If you ever use the quotient rule, as in just straight up subtracting, you always put it in the numerator. Just like I did here. You put it in the numerator. I didn't put this in the denominator. When I subtracted 2 minus 5, I kept the m in the numerator. I'm keeping the t in the numerator. Even if it came out to be t to the negative 20,002nd, I don't care. I'm keeping it in the numerator. Whenever you use the quotient rule, whenever you actually subtract, keep it in the numerator. Okay? But you'll see what negatives really mean further down the notes. Last one, I am not going to square this entire thing out yet. Or will I? I'm not. So, instead, I'm going to start dividing. 15 divided by 9 is not going to be an integer, so I'm just going to reduce this. 15 and 9 are both divisible by 3, so that's going to be 5 over 3. There's no other x. I don't have an x in my denominator. All I have is a y down there. So I am not going to be doing anything with this x to the 3/2. I'm keeping it. I have 2 factors of y in my numerator, 5 factors of y in my denominator. If I take the 2 factors away here and 2 factors away here, I have 3 factors left. I still have that squared on the outside. Now I'm going to go through and multiply everything with the exponent of 2. So I'm going to have 5 squared. X to the 3/2 squared is really just 3/2 times 2, which is 6 over 2. 6 over 2 reduces to 3. 3 squared and y cubed squared, so 3 times 2 is 6. If I want to reduce it even more, it's going to be, I'm sorry that my paper's getting crooked because I write weird. 5 squared is 25, x cubed. 3 squared is 9, y to the 6th. Boom, done. All right, it's a little cat right there, a little cat humor. So 25x cubed over 9y to the 6th. Again, guys, that's the quotient rule. It can get a little bit confusing when you start incorporating more rules into one, but you get to hang with it with more practice, guys. It shouldn't be too bad. Let's move on to the negative exponent rule. Now, if I'm looking at my second half of my notes, and let me hit the focus button because that's god-awful. There it is. I'm not going to tell you what the negative exponent really means right now, even though it says, what does it really mean? And that's why the cat's there. But I'm going to go through an exercise, and so you guys can hopefully get it to yourself. So we know that 2 to the 4th is just 2 times 2 times 2 times 2, which is 16. We know 2 cubed, which is 8. We know 2 squared is 4. We know 2 to the 1st is 2. Now, if you guys don't know what 2 to the 0 means, you're about to find out. If we follow this pattern, if I'm looking at this column, 16 to 8, I divided by 2. 8 to 4, I divided by 2. 4 to 2, I divided by 2. So as you see, as we get rid of a factor of 2, we're actually dividing by 2. So if I follow that, 2 divided by 2 is 1. 2 divided by 2 is 1. This actually holds true for anything. Anything to the 0 power, anything at all, is 1. It's not an exponent of 1, it's just 1 done. It's 1, okay? Anything to the 0 power is 1. If I keep following this pattern, as you can see, we're decreasing our exponents by 1, and we're starting to get into the negative exponent range. So pay close attention. If I keep following this pattern, if I divide by 2, 1 divided by 2 is 1/2. If I divide by 2 again, 1 divided by 2 is 1/4. So you're probably wondering, like, Mr. Z, what's going on? I'm not really understanding it because I'm just tired. Hit the pause button, guys. Try to figure out what's happening with these negative exponents. Take a close look at what was going on. If you want to continue further with the chart, you can do 2 to the negative 3, you can do 2 to the negative 4, you can do 2 to the negative 5, and figure it out for yourself what's going on. Hit the pause button real quick. I'm going to keep moving on. The observation. As I keep dividing by 2, when I got to my negative exponents, my base basically switched to the denominator. And that's what a negative exponent does. That's what a negative exponent does, okay? It switches the position of the base. Mr. Z, that's not 2 squared, that's 4. Well, guys, 2 squared is 4. If I were to do 2 to the negative 3, it'd be 1 over 8. If I did 2 to the negative 4, it'd be 1 over 16. The negative sign switches the location of the base. One thing that I saw on Pinterest, because, you know, Pinterest is awesome, right? you know what I'm saying, is one teacher wrote negative sign, change over the line. Or something like that. I'll look it back up later. I'll give you guys the real saying. But it's something like that. Negative sign, change over the line. Basically meaning, if you have a negative sign, flip it over the line. Okay? If it's in the numerator, take it to the denominator. If it's in the denominator, flip it over the line to the numerator, and then go with that. Okay? And you're going to see what I'm talking about. 9 to the negative 2. In order for something to be completely simplified, you cannot have a negative exponent in your answer. So this up here would not fly. This is not the simplified answer. This is. Okay? There's nothing else with negative. So, again, I cannot just have 9 to the negative 2. This implies, again, negative sign, change over the line. 9 to the negative 2. If I change over the line, remember it's 9. That's really what we have. I'm going to switch it. So I'm going to put this 9 and bring it down. But Mr. Z, what's left on top? There's nothing in my numerator anymore. Guys, if there's nothing there, you always put a 1 there. So again, with a negative exponent, you just flip the location of it. You flip it over the line. Maybe that was it. Negative sign, flip over line. Yeah, that was it. Negative sign, flip over the line. So, and we know 9 squared is 81. Let's look at the next one. Mr. Z, the negative is in the denominator. I'm so confused. Oh my God. Guys, again, negative sign, flip over the line. So even if my negative is in the denominator, I flip it to my numerator. And that's my answer. It's just x to the 5th. There's no reducing. There's no nothing. So again, notice how I'm flipping it over the line and I'm making it positive. That's the whole thing with negative exponents. Flip it over the line and make it positive. Okay? Next one. Uh-oh. I have a lot of stuff going on. I have a quotient rule and I have negative exponents. OMG. I'm so confused. So guys, when you have this ahead of you, you want to take your time and yeah, that was helmet to helmet. Watching the Bills game right now, guys. If you're not watching football, get ready for the Panthers at 4:20 and start rooting for them. But back to the task at hand. I gotta stop watching this game. Flip your negative exponents before you do anything. So, for example, s cubed. That's not negative. I keep it. T to the negative 2nd. Well, again, negative means negative sign, flip over the line. I'm going to flip this down here. Okay? Now, I go down. S to the negative 2. Again, negative sign, flip over the line. I'm going to bring that up. T to the 7th is positive. I don't change it. Now, notice how our like bases are on the same denominator or in the same numerator. Now we just have product of powers. 3 over 6 reduces to 1 over 2. S cubed times s squared. Again, product of powers means I add the exponents. Add them. S to the 5th. T squared, t to the 7th. I have 2 factors of t. I have 7 factors of t. That means I have 9 factors of t. 1 times s to the 5th over 2 times t to the 9th. All right? So, guys, that's the extent that we're going to get into today in terms of difficulty. We're not going to get much crazier. Starting later on, after the whole notes and things happen, you guys will be getting much more difficult problems where you have to keep track of all of the exponent laws at once, and it can get kind of messy. Again, take your time, step by step. We have a bigger problem. Reduce it to smaller, individual smaller ones as you move on. Hit the pause button. Try these on your own. If you can reduce it even more after you flip the negative exponents around, reduce it even more. Guys, remember, only negative exponents are flipped. A negative sign in the exponent area. If the number itself, if your coefficient is negative, you do not flip it. A negative coefficient does not go with the rule. It's only negative exponents. Okay? Hit the pause button. Go through it. I'm going to start doing these problems. Hopefully you guys get them right. 2x squared over x to the negative fourth. Again, negative sign. Flip it over the line. So I'm going to take this x to the negative fourth. I'm going to bring it up. 2x squared. X to the fourth. Mr. Z, what happens to my denominator? Again, there's a 1 under it. You don't have to write that. That's just being redundant. It doesn't matter. 2. I have 2 factors of x here, 4 factors of x here. That gives me 6 factors of x altogether. 6 factors of x altogether. 2x to the 6th. 2x to the 6th. Next one. Negative 25, a to the negative 5th, b cubed over 5ab to the negative 4th. Again, I'm going to flip all negative exponents I see. I'm going to flip all negative exponents I see. This is not a negative exponent. It is a negative coefficient. It doesn't follow the rule. A to the negative 5th. A to the negative 5th. Again, I am going to negative sign, flip over the line. I'm going to bring it down. B cubed, it's positive, I keep it. A, it's positive, I keep it. B to the negative 4th, it's negative, I flip it. Now again, it just so happens, guys, that our exponents are, our like bases are on the same numerator, denominator. That's not always going to happen. It's just how these are working out. So don't think that's like a pattern you have to follow, because it's not. Negative 25 divided by 5 is, we know, negative 5. B cubed, b to the 4th, 3 factors of b, 4 factors of b. I have 7 factors of b. Then down here I have 5 factors of a. I have 1 factor of a, that's a to the 6th. Boom! Now, ooh, oh, you tripped! Oh my god. So, again, watching the football game, guys, my bad. Last one, if I'm looking at this, I keep the negative 8 and 12 where they are, unless they have negative exponents, which they don't. The 8 is just negative itself. X squared is positive, y to the 8th is positive, z to the negative 5th, negative sign, flip over the line. X to the 4th is positive, y to the negative 7th, flip over the line with a negative sign, or negative sign, flip over the line. It rhymes. It's kind of cool, right? Yeah, sure. And then z to the 7th. And guys, if you're wondering the order I'm dealing with my numerator first, then I'm dealing with my denominator. I'm dealing with my numerator first, then I'm dealing with my denominator. Now, I have everything situated. I can start dividing and multiplying. Negative 8 over negative 12 is just negative 2/3. Now, I have x squared up here, x to the 4th down here. I am not using the quotient rule. I am not. I have 2 factors of x. I have 4 factors of x. If these 2 factors go away, 2 of these factors go away. That means I have 2 factors left over in the denominator. 2 factors in the denominator. Y to the 8th and y to the 7th. 8 and 7, that make 15. Z to the 5th, z to the 7th, that makes z to the 12th. Guys, that's one of the more difficult ones you're going to be seeing. Again, it's not difficult, it's tedious. So just take your time with it. Everything should be good. Guys, those are the notes for today. On the back, you're going to find the assessment. And as you look through it, again, guys, it's questions very similar. Now, obviously, yes, you have your notes on the back side. But guys, refrain from using your notes. This is not for a grade. This is just to see how much you know. Okay? This is not for a grade. This will put you in your pathway. So please, if you use your notes, guys, that's really fudging the numbers a little bit, and that's going to put you in a higher pathway than what you deserve. And if you belong in a lower pathway, guys, I have activities and tasks for you to really bring up your knowledge of this. But if you get thrown into a higher pathway, you're going to struggle hard. So again, be fair, be truthful, be honest with yourself, and try these problems without looking at your notes. Okay? or even rewatching these videos. So do these 5 problems. Try your best. We'll see what happens. Again, hope you like the notes. Hit the subscribe button because shameless plugs in every video I have. I'm going to make myself a YouTube star by the end of the year, hopefully with more than 15 subscribers. That's the goal. I know that's a weak goal. Otherwise, guys, good luck. Godspeed. I'll see you later.